Hi everyone. Now I want to walk you through week 2 pre's machine learning code exercise that we're doing together. Now if you followed along in our notebook, here I have it loaded up on my Mac. If we scroll down, there's this pre-class work section. And in particular, there's quite a lot of code that you have to do the normal data science part of a machine learning problem. However, not all of it is integral to actually doing the machine learning itself once you have a good understanding of the data. So let's just jump to that part. So this summary section, I'm going to narrate for you. Okay, it was quite a lot to absorb in all of the previous section, but while those are really important for understanding your data, really what we want to concentrate on in this particular summary is just the relevant part of the code, which is actually really compact. So here's a tidy, compact version of just the Naïve base code that we discussed in the pre-lecture videos in the PowerPoint. So I'm going to walk you through this. It's only about 20 lines of code, as you can see here. And if we just jump to this particular cell and we run it, it will come back after it connects to a runtime over here, right? And then it's going to run this cell and then output the answer, right? So we've actually just gone ahead, loaded up the entire data set, created the data into training data and the answers, split it into test data, and then run a naive Bayes algorithm. So let's step through all of these parts of the code, shall we? All right. The first important thing to do is to note that in many programming languages, such as Python, we actually have to import some libraries. These libraries are like predefined functions or routines that we can find that are really helpful for doing lots of things. So for example, in Python, we have this NumPy library. Okay, this NumPy library does a lot of the numeric calculations, especially for all of the matrix operations in linear algebra. But aside from that, we also need a very helpful thing that you may have learned in data science before, which is the Pandas pre-processing toolkit. It basically handles putting data into data frames and helps to do with a lot of data manipulation. So those are all just to do the plots and graphs that we saw earlier if you've gone through the notebook yourself. But actually what we want to do is just apply machine learning, right? So we're going to use the sklearn library, which is going to feature in most of what we do except for the deep learning parts of the work, all right, in the course. So we've loaded up the Naïve Bayes particular classifier. This classifier is a little bit different than the one that you're actually going to be executing in class because it has some other tricks up its sleeve. And we're also going to import the model selection libraries, which is going to help us split the data into training and test. So then line 9 just does one thing. It reads in the CVS from this particular server at UC Irvine. So UC Irvine is a particular university that houses an archive of a lot of machine learning data sets that people use for research, but also to teach classes. Okay, so we're using the wine quality data set. You can actually go ahead, I'm going to do it here, load this data up in a browser. Okay, let's see whether that's going to work. Copy, run it in there, and then we're going to get it down as a CSV file. I'm going to open that file, and it's giving me numbers from Apple, and then there you go. So this is what the data looks like when it comes out of the download. It's actually in a comma separated format, but most spreadsheets in spreadsheet programs such as Apple's Numbers, but more importantly probably Microsoft Excel or Google Sheets will understand this format. So what this is basically it's got a couple rows of information to tell you the header, what are the different column names, and then the rest of the file is just a text file that has comma separated values for all of the different commas. So there's a 7, comma 0.27, then a comma, then 0 0.36, etc. And they correspond to the first three columns of fixed acidity, volatile acidity, and citric acid in a particular white wine. Okay, so this isn't pretty scary. You know, this is just the data that comes down. It's just like if you had gone and saved your Excel spreadsheet as CSV. In fact, you can do this in numbers here. Save as, and then you can choose it to be in a certain format. I'm not going to do it right now. And then you'll have it as a CSV file. So when you have a CSV file, you can load it in Google Colab using the Pandas library, which is PD here, right? And we're just calling a function of that library called read CSV, and it's going to import it into a variable called data frame. Okay, so we could give it any name, but data frame or DF seems pretty good. And the DF object allows us to create new columns, and so that's what we're going to do here. We're actually going to take the good column as the Y to predict, meaning the class that we want to predict as a binary class, where we're going to use a quality of 7 or better, because if you've gone through the pre part of this, you would have noted the quality factor is a numeric column. So you can actually see this if we go back to the numbers file. See, oops, I threw it away. Never mind. That particular column in our spreadsheet is numeric. And so what we can do is just condition on it. We can say if the quality of that column was above 7, we're going to call it a good wine. Otherwise, we're going to call it a not good wine. Okay, so we want to distinguish good buys, for example, for wine. So we're going to create a new column called DF good wine, and we're just going to insert good as the column name, the value for that column for a particular row, if it's better than 7 and not good otherwise. Of course, we then have to actually drop the column that has the quality, otherwise it'll become part of our training data. And of course, training data, the column of quality accurately predicts the good wine binary classification, so we have to leave that out. Okay, so then the next thing we're going to do is we're going to take the data frame and then split it into two parts. One is for the X, which is our observations, and then the Y, which is the good wine part. So now we've separated into the data matrix X, and then a vector of answers Y. Okay, so that's great. That's our X and Y, but we still have to split the data again. Why is that? Because we have to do training and testing. Just like we would teach you in a class, we wouldn't assess you on exactly what we've taught you in class. We're letting you try to generalize from what you've learned in class. So we have to give you a test. So similar to the machine learning algorithms, we're going to split the data up into a training sample, which we're going to give the machine learner to look at to make a model. And then we're going to split part of the data for testing. Withhold that part of the data for testing. And here what we're going to do is we're going to take some 20% of the data, and we're going to save that for testing purposes, where the algorithm is going to see the column values in the input, but not be able to see the answers in the Y column. Okay, we're going to pick 20% of it randomly, and then now we've done everything. The easy part is really just running the machine learning algorithm. Okay, and we're going to do that here. We're going to load up Naïve base from the library, which is over here, right? And then we're going to run it, right? And this is the only line that does machine learning. Ta-da! Right? So it just says, take the library of machine learning, NB, call the fit function against the training data and the answers for the training data. Okay? And then we're done. We have a machine learning model. It's an object, and we can ask that object later on to score itself. You know, how well does it do on the training data? So this is cheating of some sort, because we're predicting things that we've already learned, and in this case we're doing testing. So we're giving new instances which it's never seen before, and we're asking the system to predict its accuracy. So at the bottom here we can see Naïve Bayes does, you know, pretty well. Gets 96% on this data set, on both the held out 20% as well as what it's learned already, what it's been exposed to. It can generalize, but it has some error there. It gets only 96% of the data. So same accuracy for training and test. Okay, with that, I hope you're a little bit more confident about how to do machine learning. It's just really one line of code, line 23 in this case. And congrats! You're done and you're ready for class next Thursday. See you!